Okay, let's talk about Node.js. It's actually really cool and surprisingly simple to grasp. Basically, Node.js is a place where you can run JavaScript code ** outside * of your web browser. That might sound weird, but it opens up a huge range of possibilities. It's a JavaScript runtime environment. Think of it as an engine that interprets your JavaScript instructions on the server or even directly on your computer. It's been used to build everything from real-time chat applications and online games to the backends for many websites and mobile apps. Plus, you can use it to create handy command line tools. A lot of developer stuff is actually built with Node.js. Okay, let's dive into how Node.js actually works under the hood. It's a really clever design. The most important thing to understand is its event loop. It's constantly checking if anything needs doing and then handles them one at a time. Because of this non-blocking /o, Node.js can handle tons of requests simultaneously without getting bogged down. It uses Google's Vite engine, which is super fast for JavaScript, and has the solid core written in C++ to keep it all stable and efficient. Okay, let's talk about what makes Node.js so special. The big one is its non-blocking /o. Think of it like a waiter who can take several orders at once without getting stuck waiting for each dish to come out. This means it handles lots of requests really efficiently. You also get the benefit of being able to use JavaScript everywhere, which makes development easier and faster thanks to NPM, which is basically a huge library store. And because Node.js runs on Vite, it's incredibly speedy. Okay, let's talk about synchronous versus asynchronous programming in Node.js. Synchronous code is like a line. You have to finish one thing before starting the next. It's simple to understand, but if something takes a while, your whole program waits. Think of it like a single-lane road. Everything has to go through sequentially. Now, asynchronous programming is how Node.js really shines. It's like a multi-lane highway. You can start several tasks at once and they don't block each other. When one finishes, you get notified and you move on with the others. This allows Node.js to handle tons of requests at the same time. That's what makes it so scalable. Okay, let's talk about something super important in Node.js, the event loop. Basically, it's how Node.js handles tasks without blocking your program while waiting for things like network requests or file operations to complete. It's a single-threaded process, meaning only one thing can happen at a time, but because of this loop, it feels incredibly efficient. The event loop constantly monitors a queue for new events and then grabs the appropriate callback function and runs it kind of like a waiter taking orders and delivering food. Okay, let's talk about callbacks in Node.js. Think of them as a way to handle things that take time, like reading files or making requests to other servers. Before synchronous programming was really popular, JavaScript had to wait for one thing to finish before starting the next. That could cause problems when dealing with /o because it would block the main thread. Callback solved this by letting you give Node.js a function that ** be executed once everything is done. It's like saying, hey, when this long process finishes, please run this code for me. It's a really fundamental concept to understand in Node. Okay, let's talk about streams in Node.js. They're really important for handling big files and network operations efficiently. Think of it like this: instead of trying to load a massive file completely into your computer's memory at once, which could slow things down and use up tons of RAM, streams allow you to read and write data bit by bit as it becomes available. This makes them incredibly memory-friendly and boosts performance. There are different kinds of streams: two readable ones for things coming ** in **, writable ones for things going ** out **, and then duplex streams that can do both. Understanding these types will really help you work with Node.js effectively. Okay, let's talk about buffers in Node.js. Imagine you're working with files, maybe images or audio. JavaScript primarily deals with text as strings, but sometimes we need to work directly with the raw data inside those files. That's where buffers come in. They are basically containers for binary information. Think of them like dedicated boxes for holding different types of data. Because Node.js uses 64-bit processors, using buffers efficiently is key. It's a crucial difference between how strings and buffers handle data. Buffers store the raw bytes directly, whereas strings are text-based. Let's talk about how Node.js schedules tasks for later execution, specifically process, next tick, set immediate, and set timeout. Think of them as different levels of priority in the event loop. Process, next tick, is the highest priority. It gets run immediately after the current iteration of the event loop finishes. It's great for things that need to happen right away, like processing a database query or updating internal state within your application. Set immediate sits just below it. It runs after all /o events have been handled and before process, next tick. This makes it perfect for tasks that don't require immediate action but should still be processed soon after the current operation completes, like handling a user request or updating the UI. Finally, set timeout is the lowest priority. It only runs after the specified delay is passed. It's ideal when you have a task that can wait a little bit, maybe fetching data from an external API or performing a long-running calculation. Let's talk about NPM, which stands for Node Package Manager. It's basically the go-to store for all the code you need to build your Node.js applications. Think of it like installing apps on your computer. NPM lets you easily add pre-written JavaScript libraries and tools that do everything from handling user input to connecting to databases. The most common commands are npm install to bring in new packages, npm uninstall to remove them, npm update to get the latest versions, and npm search if you're looking for something specific. Managing dependencies efficiently is key to successful Node.js development, and that's exactly what npm helps with, making your projects easier to build, maintain, and share. Okay, let's talk about package.json. It's your project's recipe book. Inside, you'll find sections called dependencies and dev dependencies. Dependencies are the things your application needs to run smoothly. Think of them as core ingredients. These libraries are essential for everything from handling requests to displaying data. You install them using npm install, and they're used when you actually run your app. Now, dev dependencies are different. They're tools that help you build, test, and maintain your project during development . These aren't needed in the final product deployed to production. Think of things like testing frameworks or code linters. You install them with npm install save dev, and they come into play during the development process, like when you're writing tests or fixing bugs. Okay, let's talk about the package lock.json file. It's a really important little file in your Node.js projects. Think of it as a detailed record of all the packages your project relies on, and which versions of those packages are being used. It's like creating a blueprint for how your project should be built, ensuring that everyone working on the same code gets the same results. This is super helpful to avoid problems with different versions causing conflicts or unexpected behavior. Plus, it speeds up installation times because Node.js knows exactly what to download. Okay, let's talk about require. In Node.js, require is like a module loader. It's the tool you use to bring in code from separate JavaScript files. When you call require some module, Node.js goes on a search for that file in your project. If it finds it, it runs the code inside and then gives you back whatever that code exports. It's really how we organize our larger projects into smaller, reusable pieces of code. Okay, let's talk about how Node.js handles modules. You've probably heard of CommonJS and ES modules, and they have some key differences. CommonJS, using the require function, loads everything up front when your application starts. This can make initial loading slow, kind of like waiting in a really long line. And because it's synchronous, if one module takes too long to load, it blocks the whole process. ES modules, on the other hand, use import and export. They are loaded only when you need them, making for smaller initial downloads and preventing that blocking issue by loading modules asynchronously. Okay, let's talk about global objects in Node.js. Essentially, these are built-in JavaScript objects that are available everywhere in your code. No need to import them. The process object is really important. It gives you information about the current Node.js process, like command line arguments and how to handle signals. Then there's module, which is tied to how we load modules with the require function. and of course require itself. That's our main way of bringing in external code. You might also encounter global, although it's less frequently used these days. Finally, don't forget about the buffer object for working with binary data. It's a fundamental part of Node.js. Okay, let's talk about middleware in Node.js. Think of it like a series of steps that happen before your main code handles a request, kind of like an assembly line. These functions are designed to do specific things, such as checking if a user is logged in, logging important details about the request, or even making sure the data the user sends is valid. They're super useful for adding extra functionality to your Node.js apps without cluttering your main route handlers. Okay, let's talk about Express.js. It's a really popular tool for building web applications using Node.js. Essentially, it's like a set of helpful tools that make routing, directing incoming requests to the right part of your code much easier and less complicated. It also provides great support for middleware, which are like extra functions you can add in between where a request comes in and where the response goes out. This handles things like logging, security, and error handling without needing to write tons of repetitive code. Because Node.js is already designed to handle many requests simultaneously efficiently, using Express makes it super effective for creating scalable web apps. Let's talk about routing in Express.js. It's absolutely fundamental. Think of routing as the system that decides what happens when someone visits a specific page on your website or app. Essentially, you tell Express which URL should trigger which function to handle the request. You define these routes using methods like get, post, put, and delete. Each method links a particular URL path to a function. It's like saying when someone goes to this address, run this code. It's really important to keep your route definitions clear and organized for a maintainable application. Let's talk about cross-origin resource sharing. It's a security feature built into web browsers to prevent one website from accessing data on another without permission. Think of it like this. Your browser has rules about which websites can ask for information from other sites, and CORS is how you tell the browser who's allowed. In Node.js, we configure our server to send a specific header called access control allow origin, telling the browser which domains are safe to access our resources. You'll often see it set to * for development, but remember, in a real production environment you should restrict this to only the sources that actually need access. Okay, let's talk about how we deal with errors in our Node.js code. It's really important to handle errors properly. If you don't, things can go seriously wrong. There are a few main ways we can do this. We can use try-catch blocks, which give us precise control over what happens when something goes sideways. Another good approach is an error-first design, where we assume that something might fail and build our code to handle it in advance. And of course, with asynchronous operations, we need to catch errors from async functions using try-catch. Finally, there's the uncaught exception handler, but use this carefully. The most important thing is to log your errors effectively, including all the information you need to figure out what happened. Don't just ignore them. Let's talk about environment variables. Think of them as settings that tell your Node.js application how to behave, but instead of hard-coding those settings directly into the code, they live outside it. This is really important because it lets you easily switch between different configurations for development, testing, and production without having to change your actual code, which makes things much more flexible and secure. You access them using a special object called process.env in JavaScript. It's like a dictionary where each key represents a variable name, and the value is what's stored under that name. For example, you might have an environment variable for your database URL or the port number to listen on. These variables can be really helpful for keeping your secrets safe and making sure your app works correctly in all its different environments. Let's talk about managing settings in Node.js. It's super important. Don't just write everything directly into your code. That makes things really difficult when you need to change a setting for different environments. The best way is usually using environment variables. They are external and let you easily switch between development, staging, and production without changing the actual code. You can also use env files locally, which are great for local development. And if your configuration gets quite complex, consider using dedicated configuration files like JSON or YAML. Just remember to use a good library to help manage all of it. That will make things much smoother. Let's talk about clustering in Node.js. Essentially, it lets you run multiple copies of your application all at the same time on one computer. Think of it like having several little workers tackling tasks instead of just one really busy one. This is great because it helps your app handle more users and requests smoothly, especially when dealing with a lot of traffic. And if one worker has a problem and crashes, the others keep going. That's important for reliability. Clustering is often a first step towards scaling up to multiple machines eventually. Okay, let's talk about securing your Node.js application, specifically authentication and authorization. Authentication is all about verifying **** user actually is. We can do this with traditional username/password logins, which always need strong password hashing like bcrypt to keep those passwords safe. Another popular option are JWT or JSON Web Tokens, which allow you to create stateless sessions and have the server issue tokens that the client uses for subsequent requests. Then there's OAuth 2.0 and OpenID Connect. These let users log in with their existing accounts from services like Google or Facebook without needing a separate username and password. Now, once we've confirmed **** someone is, we need to figure out what * they are allowed to do that authorization. There are a few ways to handle this. Role-based access control assigns users roles with specific permissions like admin or editor. Attribute-based access control looks at various attributes like the user and the resource being accessed to decide whether access should be granted. And finally, access control lists let you define very granular rules for individual resources. Okay, let's talk about JWT JSON Web Tokens. They're like digital badges of identity that are super useful in Node.js and web applications. Basically, a JWT is a compact, self-contained way to securely transmit information between servers and clients. Think of it as a tamper-proof receipt. A Node.js app creates these tokens using a secret key, adding claims like user ID or roles. It then signs the token with a private key, making sure nobody can fake one. The client sends the signed JWT back to the server, where we verify the signature using a public key. This lets us confidently trust the information inside the token, perfect for authentication and authorization, session management, or even connecting microservices. Okay, so connecting your Node.js app to a database is a really important step in building anything beyond a simple static website. There are several popular databases out there like MongoDB, PostgreSQL, and MySQL, each with its own strengths. You'll want to pick the one that best fits your project's needs. The key thing is using a driver library, which makes interacting with the database much easier. Libraries like Mongoose for MongoDB, PG for Postgres, or MiskTool for MySQL handle all the low-level details. I've shown you a simple example using Mongoose to connect to a MongoDB database. Just remember to adjust the connection string and the driver based on what database you're actually using. Okay, let's talk about databases for your Node.js projects. When it comes to choosing between MongoDB and traditional SQL databases like PostgreSQL or MySQL, there are some key differences. SQL databases organize data in structured tables with rows and columns. Think of spreadsheets. They have a strict schema, meaning you need to define the structure upfront. This can be great for consistency, but can make changes tricky. MongoDB, on the other hand, uses a document-oriented approach. It stores data as JSON-like documents within collections, which gives it a lot more flexibility, perfect if your data is constantly changing. SQL databases are fantastic for complex queries and joins, while MongoDB shines when you need to scale easily, especially in a Node.js environment. Ultimately, the best choice depends on what's most important for your project. Okay, let's talk about RESTful API. Essentially, they are a standard way for different applications to communicate with each other over the internet. Think of them like well-organized menus in a restaurant. Each item resource has a clear address and you use specific actions, get, post, etc., to interact with it. They rely heavily on HTTP methods, and data is usually exchanged in a structured format like JSON. The important thing to remember is that they're stateless, meaning the server doesn't need to keep track of past interactions. Each request stands alone. Now, when building these API using Node.js, we often use Express.js, which simplifies creating endpoints. As you can see in this example code snippet, we define a route for /users and respond with some user data in JSON format. Let's talk about how to handle tasks that need some time and don't require your main program to wait. Node.js has a few really useful ways to do this without slowing things down. First, you can use child processes. These are like launching separate mini programs just for those tasks. Then there are worker threads, which let you run parts of your code concurrently within the same process. And finally, simpler methods like set timeout and set interval can be used for quick, one-off or repeating jobs. Remember to choose the right tool for the job. Okay, let's talk about how Node.js spawns new processes. We have three main methods: fork, spawn, and exec. Fork is like making a quick copy of your current process. It's lightweight because it shares memory. Spawn creates a fully independent child process with its own environment, giving you more control over things like commands and arguments. And then there's exec, which completely replaces the parent process with the command you specify. The parent just shuts down immediately. Each of these has slightly different behaviors. Fork's fast, spawn's flexible, and exec's, well, it takes over. Let's talk about child processes in Node.js. Think of them as mini versions of your main application running alongside it, all working independently. They are super useful when you need to do some heavy lifting, like handling a really complex calculation or processing a large file without slowing down your main app. Using them can also help isolate problems. If one child process crashes, it shouldn't bring down the whole thing. And they make building larger applications much easier by letting you break things up into separate, manageable modules. Okay, let's talk about promises in Node.js. Asynchronous operations are a big part of what we do, and before promises, we use callbacks, which could quickly become really complicated to manage. Promises provide a much better solution. They are like placeholders for the result of an asynchronous action. They can be either pending waiting, fulfilled successful, or rejected failure. Essentially, they make handling these asynchronous tasks much cleaner and easier to understand. Let's talk about async/await, a really important concept for writing clean asynchronous code in Node.js. Before async/await, handling things like network requests often involve nested callbacks or promises, which could quickly become hard to follow. Async/await essentially makes asynchronous operations look and feel more like regular synchronous code. It's built on top of promises and uses the async keyword to define an asynchronous function and the wait keyword to pause execution until a promise resolves. This simplifies error handling too. You can just use standard try-catch blocks. It dramatically improves readability and helps you avoid the confusing callback hell we used to deal with. Okay, let's talk about process argv and process env. Think of process argv as the direct input you give your Node.js script when running it from the command line, like arguments you type in. It's an array that holds everything entered at the terminal. Then there's process env, which is a bit different. It's an object containing environment variables. These are settings that tell your application how to behave, things like database URL or API keys. Using process env keeps your configuration separate from your code, making it much easier to adapt the app in different environments. Okay, let's talk about socket. It's a really handy library for Node.js if you need to build applications that require real-time communication. Think instant chat or live updates. Basically, it uses WebSockets under the hood to create a persistent connection between your server and clients. If a client can't use WebSockets socket.io has clever fallback mechanisms to still work smoothly. It's bidirectional, so both the client and server can send data whenever they need to. This makes it perfect for things like chat apps, live games, or any application where you want information flowing back and forth in real time instantly. Okay, let's talk about handling file uploads in Node.js. We'll be using Express for our web server, and Malta as middleware. It really simplifies the process of passing multi-platform data that contains files. Malta takes care of all the complexities of understanding what type of file is being sent and where to save it. We'll also need a storage solution like your local file system, or maybe even something more robust like AWS S3. The example code shows how you'd configure Malta to store files in a directory named uploads. Remember to handle cases where no file is uploaded gracefully. Okay, let's talk about validation in Node.js, a super important part of any web app development process. There are actually some fantastic libraries available to make this much easier than writing everything from scratch. Joy is a really popular one. It's extremely flexible and allows you to define your data schemas clearly and then automatically validate incoming requests. Express Validator is great if you're already using the Express framework. It's very simple to use and integrate. Atch is incredibly fast, especially when dealing with large amounts of data. And Yup offers type safety, which is really beneficial for larger projects. Let's talk about keeping our Node.js app safe. Security is super important, and there are a few key things we need to be aware of. First off, always double check everything coming in from users. That's input validation. This helps us avoid attacks like SQL injection or cross-site scripting. Then, rate limiting can stop attackers from flooding your server with requests. Make sure you're using HTTPS and a strong TLS configuration to encrypt all data traveling between the client and server. Next, keep an eye on your dependencies. Use npm audit to find vulnerabilities and update them as soon as possible. And finally, never ever put sensitive information like passwords directly in your code. Use environment variables instead. Authentication and authorization are also key. Make sure users are who they say they are, and that they can only access the things they are allowed to. Regularly scanning with tools like Sonaquabelt or Snike is a good practice too. Okay, let's talk about rate limiting. It's a really important topic when building robust API. Essentially, it's like setting limits on how many requests someone can make within a certain time frame. Why do we need this? Well, it helps protect against things like denial of service attacks and stops malicious bots from overwhelming your server. There are several libraries available in Node.js to help you implement rate limiting. Express rate limit is one of the most common and easy to use, and Bottleneck gives you more fine-grained control. Let's take a look at a simple example using Express rate limit. It's all about configuring a time window, setting a maximum number of requests, and ensuring that your headers are properly set for browser support. Okay, let's talk about logging in Node.js. It's super important for keeping track of what's happening inside your application and quickly finding any issues. You won't find built-in logging, so you need to use a library like Winston or LogLevel. These libraries let you set different levels of severity for your messages, from detailed debug information to critical errors. It's really key to log important things like user actions or database connections. That way, if something goes wrong, you can easily track it down and fix it. Okay, let's talk about writing unit tests in Node.js. It's super important for building reliable code. We'll start by looking at some key concepts like test-driven development and how to isolate individual units of your code. There are a few popular frameworks you'll want to know about, including Jest, Mocha, and Jasmine. I've included a brief example using Jest showing how you can create a simple test case for an add function. Don't forget to run those tests after you write them. Okay, let's talk about testing frameworks in Node.js. They're crucial for ensuring your code works correctly. A few popular choices include Jest, developed by Facebook, which is really easy to get started with and has some built-in features that are super helpful. Then there's Mocha, a very flexible framework that lets you pick exactly what libraries you want to use alongside it. Jasmine is also great for BDD, behavior-driven development, making sure your tests align with the expected behavior of your application. And finally, Vitest is a newer option that's incredibly fast thanks to its integration with Vite. Don't worry about memorizing all of these, just know they exist and each has a specific set of advantages. Okay, let's talk about memory leaks in Node.js, a really important topic for any developer building long-running applications. Memory leaks happen when your program keeps holding onto things it no longer needs, preventing the garbage collector from cleaning them up. Common causes include forgetting to remove event listeners or closures that are accidentally keeping references alive. To find these leaks, you can use tools like Heap Snapshots and Node.js profilers. And the best defense is a good offense. Always remember to clean up resources when they are no longer needed, clear timers, and be careful about how closures work. Okay, let's talk about keeping an eye on how your Node.js application is running. Profiling and monitoring are essential for finding performance issues and ensuring everything's smooth. You have a few great options available to you. First up, there's Node Inspector, like a really detailed debugger that can help you zero in on exactly where slowdowns are happening. Clinic.js is another excellent choice. It's simple to use from the command line and gives you some quick stats about memory and CPU usage. For production environments, PM2 is your friend. It manages your processes, monitors them automatically, and restarts them if they crash. Then there's Prometheus and Grafana, a powerful combo for collecting data and creating beautiful dashboards to visualize it all. And finally, commercial APM tools like New Relic or Datadog offer even more in-depth monitoring capabilities. When selecting your tools, think about what you need and where you're running your application. Okay, let's talk about graceful shutdown in Node.js, a really important concept for building robust applications. Essentially, it's about giving your app a chance to finish what it's doing before saying goodbye. Without graceful shutdown, you can end up with incomplete operations, potentially leading to data loss or a bad user experience. It's like politely asking someone to wrap up their conversation instead of just interrupting them abruptly. We implement this using the process onto term event handler, which listens for a signal that indicates it's time to shut down. Inside this handler, you put all your cleanup tasks, closing database connections, saving important data, and so on. It's crucial to do these things asynchronously to avoid blocking the main Node.js event loop, which is what keeps your app running smoothly. You'll also want to handle other shutdown signals like SIGINT or SIPE, following a similar pattern. Okay, so getting that Node.js app out into the world, it's a crucial step. There are quite a few ways you can do this, and choosing the right one depends on your needs and experience level. A really common starting point is Heroku, which is super easy to use. Alternatively, you could deploy to platforms like AWS or Google Cloud, giving you more control over everything. DigitalOcean is also a good option for simpler setups. Once you've chosen a platform, containerizing your app using Docker is almost essential. It makes sure things work the same way everywhere. And don't forget about automating the process with the CI/CD pipeline. Finally, always handle secrets and sensitive information securely. Don't put them directly in your code. Okay, let's talk about what's been happening under the hood in recent Node.js releases. Node.js 20 brought some serious speed improvements thanks to a new version of the V8 JavaScript engine. It's like giving your code a turbo boost. Plus, we finally have native support for ES modules, which simplifies working with modern JavaScript packages. And don't forget about the updated Streams API. More robust and efficient data handling is now at your fingertips. Node.js 21 builds on that momentum with even more V8 engine optimizations, stability of the improved Streams API, and a boost to TypeScript support. These updates really make Node.js a powerful and modern development platform. Thank you for watching.